Welcome to my presentation. So as you can see, my presentation is about stock market prediction, right? Predict stock market future price. And for that, uh, an ensemble method is used that involves graph theory, machine learning, and deep learning models. So what is the problem this paper is addressing? So you know about the efficient market hypothesis, right? So it just says that at any point, the stock price represents the fair value considering all the different variables. And we cannot predict stock prices consistently using technical analysis or fundamental analysis. That is what the efficient market hypothesis says, and it's the cornerstone of modern financial theory. However, there are opponents. What they say is sometimes stock prices deviate from their fair value, and it is possible to beat the market. Maybe both are right. So still we use predict stock prices. Traditionally, what we use, we select a set of stocks, and then at a time interval, we try to predict the price. And want to be correct with that, right? So what we use usually use statistics and machine learning to predict, like ARIM autoregressive model and the classical machine learning algorithms, SVM or logistic regression, linear regression. That's what we use. Now, what this paper has done? This paper actually has went way beyond that, and it used graph theory and also utilized spatio-temporal relationship among stocks. Spatio means relationship in the space. I think first convert into graph and then the spatial relationship among the different stocks and their prices, and temporal just in the time interval, the relationships, and depending on that, predict the stock prices. The core idea is graph and the space. A differing idea, right? So what is the outcome by using this graph-based approach? Usually graph-based approaches perform better than the traditional approaches. But why so? As per the authors, because this approach leverages the structural information of stocks relationships. That's what helped to achieve this outcome. Now, how they achieved it, right? So they constructed different types of graphs. Like one thing is a correlation between these different stocks prices. That is one thing. And also how the sentiment, right? In the financial news, mentioning the stocks and prices. So creating graph out of that. So correlation based graph and the financial news based graph that we call causation based graph. Now, to create those graphs and stocks, we need some data. What they use? They use the Fortune 500 companies. Among the Fortune 500 companies, they selected the top 3 stocks, stocks, and they collected stock price and data for 1 day interval closing price for 2-year data and 1 minute interval data for 44 days data, 1 minute interval, right? And for the news, they utilized 1 million financial news articles. So what other work is done in terms of predicting stock market. Yeah, there are lots, but I think there are some common answer in the ARIMA, fall, winter. There are some time series based regression models to, especially the first one, autoregressive model to predict stock market prices, and LSTM, RNN, those are also used. And I think the challenge with those, they can work with one stock at a time, and each stock is studied independently, and they're independent. I think the relationship among stocks are not being studied. I think that is a core point of this paper. Okay, they are not studying them in together, studying independently. We'll be doing it together with dependency modeling and relationship finding, right? So that was the limitation. That's what this paper is trying to address. Okay, some other related work: logistic regression, SVM, Bayesian, ANN, linear discriminant analysis, or backpropagation. I think among those, I think SVM usually work better. And in one studies in SVM and ANN comparison, still SVM worked better. Anyway, so some other work tried to introduce graph-based approaches and stocks as the graph nodes and the movement of prices in the stocks that was used to create the edges. Yeah, there are very limited work before this work. So yes, what this paper has done, the others did not consider relations. It considered the relations. Then what it did, it used graph convolutional network and CNN-based deep learning network to learn and to predict, right? And it also used another traditional machine learning based, linear regression based machine learning to predict stock market prices. That's a different work, and the deep learning work, that is a different work. They also implemented ARIMA just so that they can compare everything together. Okay, so how does graph-based approach work? As I mentioned before, stocks will be the nodes of a graph. And how do they create the graph? They create graphs based on correlation among the stocks and causation based. Causation based means if they are mentioned together in financial news or not. That's it. I think the first three are correlation based. The last one is the causation based. It's a little bit more here. So first one is Pearson correlation based, then the Spearman correlation based, Kendall tau coefficient based graph, and the news convention financial causation based. Now, Pearson, it usually the linear relationships among the stocks prices that what it tells. Spearman and Kendall, they usually map the non-linear relationships. So that relationship used for getting those graphs, and news convention is there. Now, they usually use a threshold, right? If the Pearson correlation between two stocks is greater than 0.5, so there is an edge, right? And for Spearman, if the threshold is more than 0.4, and for Kendall tau coef, if the correlation is 0.3, then there is an edge between them. Now, news convention, it works. Let's say if on financial article, if two stocks are mentioned, then there will be an edge between them. Now, if another financial news mention those stocks together, then the weight will increase, right? As many mentioned, as many weight. So if we consider millions of news articles, so the edges usually will reflect the relationship and the price movement similarity. So that is the idea. Now, after we create the graph, then what we do? Yes, as you told, they create some deep learning, and deep learning has two different things. One thing is graph convolutional network, another is CNN, convolutional neural network. We can see there are multiple layers into it, right? Multiple layers. So we pass the input graph, the adjacency matrix for the input graph structure. And then this is the feature matrix. It is the time series for a particular stocks, because they consider 30 stocks, so 30 time series. Each one represents one time series for one stock. So we input it, and graph convolutional network from the adjacency matrix, it tries to understand the spatial dependency relationship among the stocks, and the CNN layer learns the uh, learns the time series dependency or the price dependency price relationships. So, and then these things are combined and sent to the next step. So this goes on like this, right? Then you have the multi-layer perception that uses some sort of linear transformations, and then convert some prices, give some output prices, predict stock market prices for individual uh, stocks, right? Predicted. So it's a one-dimensional vector with 30 different numbers, the predicted thing. And they can usually use 3 times step ahead, 3 times step, or 6 times step ahead the prices. Okay. So that was the deep neural network. But what happened for the linear model, right? Linear model, yes, definitely it also used the graph. Definitely it uses graph, but it does not input the graph directly. What it does, the graph is there. Now it uses a community detection algorithm on the graph, the Laupian community detection algorithm, right? So it applies it and finding out all the different uh, communities. For the different communities, I think for a modularity 0.4, and they find the communities and they predict stock prices for different communities, right? So let's say there's two different models. One model is the single model, another is the composite model. What happens in the single model? From a community, they pick up the stock that has the highest degree, right? And then for that, uh, they use linear regression to predict the future price. Now, what is the feature of the data they use? They use 30-day data, 1 minute interval data, and for each data point, they collect 22 different features. That is the input of the linear regression model, and they feed it and they get the output. What about the composite one? For the composite one, they actually collect all the 22 features for all of the community members, right? And then use it as a feature matrix, feed into the linear model, and to get the predicted output. That's how it works. Yeah, graph is used, but it's not that we don't feed the graph directly. Now, performance comparison. I think this linear model, graph-based deep learning model, and the other traditional model. Let's first whatever this paper has done, I think ranking of the models, which one worked best. So it looks like the deep learning model that was using the causation graph, financial news mention based graph, that performed the best, considering RMSE, mean absolute error in those metrics, right? The next one was non-linear graphs like Delta correlation, and then the Spearman, and then the Pearson correlation based graph. Okay, and then after came the traditional statistical method. Yeah, I think the linear graph-based linear model that also worked better than the traditional statistical method as per this paper. Now let's see what are the performance metrics. Let's say merged RMSE, minimum absolute percentage error, minimum absolute error. That's what they used as a performance measures. So this is the performance. So you can see all the performance. I think these are the for 3 different performance metrics, three different color for 3 different performance metrics. And all the different variations, right? The 4 graph for the graph-based correlation and causation. This is the ARIMA statistical model, and this is the graph-based linear model, single mode, and the composite mode, right? So we can see this one performed the best. You can see the RMS is the lowest. Just low RMS and lower is better. Yeah, for all of them, lower is better. This is lowest than all of them. This one maybe slightly more than this, but still it's still low. But I think in this measure, this might be the lowest. So you can easily see it, right? Okay, so 6 time steps. I think the similar results you can easily interpret it. Okay, what is the limitations of this one? One of the limitation is the uh, exploding gradient problem. I think nodes with higher degrees will accumulate large gradients. Nodes with smaller degrees will accumulate smaller gradient. That may become a problem, such as the traditional one. Now, what can we do about it? What is the future work? Is removing the exploding gradient problem. That will be definitely something to improve on, and try to use bigger graph to apply. I think as part this paper, uh, they told that other usually use 10 stocks, but they use 30. So they did a better job, but still we can do it better. And this approach we can generalize to any kind of time series forecasting, no problem. Okay, that's all on this paper on predicting stock market prices using graph theory, deep learning, machine learning. Anyway, I hope that you enjoyed this presentation. And if you have any question, I'll be happy to answer. Thank you. Have a good day. Bye. Here are the references.